Thank you, Elena. You gave away half my talk. In any case, I'm very proud to have been asked to speak to you today. I'm glad I was able to come this morning. It was a very impressive group of presentations and the panel discussion, and I was actually sorry that I wasn't able to join you yesterday. Can you hear me okay? Am I close enough to the microphone? Okay, good, good. I can see how passionate you are and engaged in these projects. I can see that you did an awful lot of work thinking about and studying these very important issues for global security. So what I'm going to try to do today is talk to you a little bit about the types of projects we do at national labs to try to address some of the key challenges, many of which you already talked about today, so I won't be probably saying anything very new in that regard. Then afterwards, I'll give you a little bit of highlights of my career, where I went, what I think about in terms of what's good to study, and what you might want to think about for your future. And then finally, I'll tell you a little bit about our Center for Global Security Research, because it's a possible opportunity for internships and resources for information in some of your future studies. So to start, I want to say that I believe that we need bilateral and multilateral arms control and disarmament engagement to move the world towards a lower risk in the use of nuclear weapons by the countries that possess them. And we also need to stop the spread of nuclear weapons and those capabilities to those that do not possess them. In nonproliferation and countering nuclear terrorism, we focus on tracking, controlling, and protecting nuclear materials and sensitive technologies, as well as stopping the spread of the actual expertise that's needed to use those materials. And so besides monitoring what already exists out there, like IAEA Safeguards does, it's key that we're able to detect any kind of clandestine activities that countries or non-state groups or actors are secretly undertaking in order to move towards enhancing their nuclear weapons capabilities. We want to know that things aren't going on out there that shouldn't be going on. So today at the Center for Global Security Research, I work on more policy-related issues, but in the first 10 years of my career at Livermore this last time, I was in the Global Security Directorate, where we studied non-proliferation, nuclear security, and arms control projects on behalf funded mostly by the US government. And we were looking to mainly address the technical, how we could use our technical capabilities to bring to bear ways to address these very important challenges. So the kinds of questions we focused on and tried to think about were, how do we detect if a country has WMD capabilities? And so it's really detection. Do they have it? And how do we stop the acquisition of expertise, materials, technology, and weapons? So we're trying to prevent the spread of nuclear weapons. How can we control the sharing of sensitive and new technology? You know, you all know we're in a very fast-paced, innovation-based world. New technologies are coming up all the time. We heard about additive just in the panel before, additive manufacturing. How do you discriminate between when a technology is being used for peaceful uses or not peaceful uses? And how do you do it in a timely way, particularly when things move really quite quickly, at least compared to how they used to? Questions of verification of correctness and completeness of declarations, for example, for the IAEA Safeguards program, but also other treaty regimes. So you've been looking at nuclear, but there's the Organization for the Prohibition of Chemical Weapons, for example, that has a very robust verification regime. And the challenges for these regimes is to detect, as I've said, and discriminate, again, as to whether or not it's for a peaceful use or not. And hopefully, by having that verification regime, we're deterring bad actors from actually trying to do it. We question whether and how we can reduce stockpiles and production of nuclear materials and weapons while continuing to protect our national security. You've talked, some of your projects very, very clearly focused on that. I know in the US we take very seriously how can we assure our allies as well as to deter our adversaries. And then in the end, can international strategic stability be maintained particularly when there are regional conflicts like India, Pakistan, like we heard today, and people who challenge that global norm, how is it that we can deal with it in the coming decades? So to answer questions such as these, one of the first steps we try to do is think about how nations what they need to know to defend themselves. And one of the most important things is to avoid being surprised. So to avoid being surprised, we need to understand the intentions and motivations and perspectives of potential adversaries and proliferators. That actually helps us to anticipate what may happen, and it allows us to focus our technical detection capabilities in the right places. So we'll have warning and we won't be surprised by it. So that tends to be the aspect that's not the technical research, but more international relations, security, political science type of research. With this advance notice of detection, we have a chance to use diplomacy to influence and possibly change the outcome. You know, we want to work to navigate an environment of mistrust and turn it into cooperation. And both technology and policy studies will contribute to these efforts. So when putting this together, I put together a list of some of the top nuclear risk challenges that came to my mind, and you've mentioned almost all of them already this morning. So I was debating whether I should go over them again, but I will quickly just to sort of set the scene. The ones that I see right off are dealing with proliferant behavior of North Korea and Iran. These problem states are putting a real strain on our global non-proliferation regime. The detection of clandestine activities, which I've just mentioned, is really a difficult challenge. And we need to do it quickly and in this environment of evolving technology. The current low point in US-Russia relations has been noted, and I think it's a troubling issue. The compliance issues surrounding the Intermediate Range Nuclear Forces Treaty, or INF, upcoming expiration of New START, both of these have been mentioned today more than once, disagreements about US missile defense intentions, which maybe you talked about yesterday, I don't know, are all evidence of the current souring environment, which is just not a good thing, in my opinion, for international security and strategic stability. This rising tension between states with and without nuclear weapons that you talked about with the Prohibition Treaty or the Ban Treaty is really quite significant. There's been, the interesting thing is it really was a civil society effort that has really brought nations together to try to do these negotiations. But there's a real clear divide between the sides, as you know, and very little real communication. I've been in any number of meetings where it's being debated, and the two sides just don't hear what the other's saying. One side says, I don't understand, you've had decades to disarm, why haven't you disarmed? You're committed to it in the Non-Proliferation Treaty. And the other side says, well, but look at the security environment, look at what we need to do to protect national security, to protect the way we think our national security, as well as our allies under our extended deterrence and our alliances. And I find that there's just no way so far that there has been a real way to have a dialogue for each side to really communicate what the strategic issues are that they're facing and feel directs them to take the positions that they do. And so maybe the education programs that you've talked about may be something that really makes a difference. In this era of limited resources, which probably is always the case, we need to keep international verification regimes effective. We have to maintain and improve their capabilities, and it's, I think, important to maintain confidence, global confidence in multilateral approaches and establish global norms. And then one of the other things that I haven't heard so much about, at least today, that you've discussed is, what do you do if you detect noncompliance? How do we, in this multipolar world, very complicated, actually have the political will and the ability to do something about noncompliance when it's detected and proven, and even find a way to come to an agreement that it has been noncompliance? On one hand, there's the technical detection capabilities and signatures. On the other hand, there's the politics of actually being able to do something about it. So to answer these and many more questions, we need experts. You all know that. We need to pursue academic and policy studies, scientific and technical research and development. We need historians, we need lawyers, we need defense and military specialists, we need international relations and political science experts, we need anthropologists, physicists, chemists, engineers, atmospheric scientists, seismologists, computer scientists, statisticians. I can keep going. This wide range of expertise is brought to the formulation of non-proliferation of nuclear security and national security policy options. The more the better. And I think that speaks to one of the comments made during the panel, which said you may not all be going into international relations or related studies as you did for these projects, but I think you can be interested in this field, study a wide range of things, and still make a contribution. Another crucial skill that I think we need more and more people is somebody who can speak between communities. My experience has been technical verification, so I'm thinking about the technical people and the policy specialists. I feel like we need interpreters. You train interpreters here in Monterey, but we need interpreters who can translate what policymakers are looking for to the technical community. And also when technical community has results and analysis, it's sometimes difficult to communicate it to a non-technical audience in a way that resonates. And so for particularly treaty verification, it's really important that these two communities work really closely together. Both for the development and the design of the regimes, but also the interpretation of the information that's collected with the verification technologies and systems. The technical people need to understand the context because, for example, you don't always use state-of-the-art technology in a verification regime. And it's hard for somebody who's working very hard to advance the state-of-the-art of technology sometimes to understand that it's not necessarily the best solution. So context really makes a big difference. So if you continue to work on national security issues, as I imagine many of you will do in the future, I would like to stress that there is no specific recipe of what to study or where to work. I think you should follow your interests and see where it leads you. So I'll tell you a little bit about how I got into the field, and I'll sort of skirt over the top. And if you have questions in the Q&A, I think there'll be plenty of time. I'd be happy to do my best to answer your questions. But I'll just reiterate that what I did is by no means a template or even a guarantee of the best way to go. I'll just tell you kind of what happened to me. I started out with no specific career path in mind. And I never would have imagined that I would be standing here speaking in front of all of you today. In the course of my career, as was introduced, I worked at 3 national laboratories, the IAEA in Vienna, a French nonprofit organization, and have supported 3 different US executive branch agencies in different capacities and at different times. So there are quite a few zigs and zags. And I guess I would say upon introspection, which I had to do in preparing this talk, my career path was influenced mostly by my desire to learn new things. I really hate being bored, and to work on issues that made a difference, even if it was in a small way. I like to work hard, I like to do my job well, and I think that it helped me find interesting opportunities. But I have to admit there's a certain amount of luck. I think we all know that sometimes you just have to be in the right place at the right time to hear about that next opportunity that gets you excited that you can work towards. I usually was willing to move around, which sometimes not everybody is able to do, but I was fortunate that I could. I took jobs that piqued my interest and would be challenging, even though I didn't know exactly where they would lead. So I would say that events that occurred while I was in high school, which is your age, really did play an important part in directing my early interests. The first Earth Day occurred in 1970 following 2 key events. I'm going to put that on the floor. I would say two key events. There was a huge oil spill off the coast of Santa Barbara, and I remember seeing the pictures of oil-covered birds and seals and sea otters, and it was really heartbreaking. And then the Cuyahoga River in Ohio caught on fire. It was that polluted. I lived in New York City, and there was a brown cloud over the city, and so it was clear we needed clean water and clean air. On April 22nd in 1970, while I was in high school, over 20 million people came out on peaceful demonstrations for the first Earth Day. And it made a real impression on me and my fellow classmates, because in our final graduating year for our yearbook, environmental protection was the theme that we undertook for that particular year. So it was, how can we save the world? And my focus at that time was the environment. But when I went to university, I didn't really know what to study. My mother wanted me to be a doctor or a lawyer, and I didn't really want to do that. So I wound up studying biology and specialized in ecology and animal behavior. This was really interesting, but it didn't lead to really a job in the field, though I had one really interesting summer working with a PhD student to study hummingbirds in Mexico, tracking them for 3 months and understanding their behaviors. To this day, I still watch hummingbirds outside my house in Oakland, California. But when I graduated, I was not interested in continuing my education at that time. You heard in the earlier panel that sometimes you want time to work. I found that I really wanted to know what skills I needed in order to really dedicate myself to studying and gaining those skills. And so I took jobs between both my bachelor's and master's and doctorate degrees. And it allows me to be able to really focus and buckle down and study once I went back to school. My choice of not diving in and becoming a real specialist as fast as I could allowed me to enjoy a broader understanding over a wider range of topics. But it comes with a price. I sometimes miss the satisfaction that would come from being a deep specialist in a particular area when I talk to someone who really knows everything about it. But I do enjoy making the connection between topics and between expert communities. I have the highest regard, though, for people who have the wherewithal and the knowledge to know what they're interested in and really dedicate all their energy to becoming that world-class expert, because we definitely need people like that. So after university was done, I was lucky to find a job as a technician sampling for environmental contamination with a research and environmental monitoring group at Los Alamos National Lab in New Mexico. In Los Alamos, I supported scientists that were studying the cycling of radionuclides deposited in the Arctic environment from the atmospheric nuclear weapons tests of the US and the Soviet Union. Samples were collected in the Arctic and sent back to us in a lab, samples of elk, fox, lichen, other vegetation, and my job was to help process and analyze the amount of radioactivity in those samples. We also took samples in the canyons around Los Alamos to look for any radioactivity as part of the environmental monitoring program that might have been inadvertently released in low-level amounts. We took samples of vegetation, soil, water, and even honey. So with this job, I was able to continue environmental work, but the focus was on radioactivity, so that was kind of a shift. Being a technician was a bit boring after a couple years, but it was a perfect segue because the contacts I made in this job allowed me to go and get into a master's program where I could study radioecology, which is the cycling of radioactivity in the environment, and get a master's degree in health physics, which is essentially radiation safety. And during the course of my master's degree, I did experimental work involving collecting field data that could be used to model how rainfall splashed up and contaminated soil was splashed up onto plants with different intensities and different rainfalls. And this small little bit of information for the model was important because if those plants are eaten by animals or humans, the contamination moves its way up through the food chain and eventually has an impact on human health. So those mathematical models allowed us to assess the dose received from environmental contamination. and I was doing my part to improve one small part of a much bigger model and contributing to the larger field of cancer risk assessment. So armed with my master's degree, I found a job at Lawrence Livermore National Lab the first time. And it was in the group to ensure that the lab complied with state and federal environmental regulations, the same ones that entered into force at the time that I was in high school and continued to be legislated in the time in between. That job was interesting, but I met at a conference somebody that was looking for a technical expert with my background of what I had gotten in radioecology. And it allowed me to become part of a team to assess the impact from iodine-131 fallout on the population of the United States from the atmospheric weapons tests in Nevada in the 1950s and 1960s. This project was to assess the U.S. population risk of getting cancer from this iodine-131 exposure. And so we had to figure out across the whole United States, decades in the past, how much people were exposed to. So we had to collect a lot of historic data and make estimates ranging from how much fallout was deposited, where the fallout was versus where the people lived, what the diets of cows were, because iodine goes through the food pathway chain from grass to cows to milk to people. So we needed to know how much the cows consumed of the iodine, how much got in the milk, where the milk was produced, and where it was shipped, and then who drank it and how much, and all for that earlier period of time. The purpose of this work was to provide data to estimate the probability that an individual got cancer as a result of this exposure. And besides the technical challenges, it was really interesting because this information was going to be used for U.S. judicial system decisions on who should get compensated by the government if the government was sued, which was starting to happen at that time. We had to communicate our results on risks to decision makers as well as those whose health might have been impacted. Well, while working on this study, the Chernobyl accident happened, and within a couple years, again, through contacts that I had at the job that I was doing, I was able to find an opportunity to go to the IAEA in Vienna. And the job there was to help complete an international database on environmental contamination deposited mostly in Europe, Russia and Europe, after the accident. But in the end, I didn't get to spend all that much time on it because the Soviet Union made a specific request, an extra budgetary request to the IAEA to conduct an independent study on the environmental health and societal impacts of the contamination released by the accident. I became the project manager, and during the early part of the study, the Soviet Union split into 3 separate countries. So we were dealing with Russia, Ukraine, and Belarus, which made this huge endeavor even more challenging. It was fascinating, but also really heart-wrenching as we traveled to the affected areas and worked to explain our results to the population in those regions. I got to work with experts from around the world, and our job was to generate credible scientific results that we could communicate to decision makers and the general population in hopes that the lessons learned could be applied in the future, help mitigate any other possible accidents that could occur. When that project was completed, I was invited to join a small French nonprofit company that worked on projects funded by the French government, industry, and the European Commission research program. At this job, I continued to study the societal impacts of the Chernobyl accident, but my main purpose for being hired was to develop a new methodology as part of a European Commission R&D program to take into account the social costs of energy fuel cycles. It was part of what was called a green accounting program that desired to incorporate health and environmental impacts into the decision-making on what energy should be developed by different nations. And we needed to do that by translating those health and environmental impacts into costs, because what we wanted to do was find a way to compare across different kinds of impacts on a common ground and incorporate in as well some very non-traditional types of impacts, like the loss of a beautiful landscape if you build a hydroelectric dam, or the loss of recreational uses down below if you stop the water. So they were all, or if you put up wind farms, what are the impacts on the environment from those wind farms, from the number of birds that get impacted? So it was very hard to figure out how to do that. It was structured in a way that there was an international team across many different countries, and each team would develop a different methodology for a different type of fuel. So there was a team that looked at wind, biomass, nuclear, coal, oil, gas, and the hydroelectric fuel cycles. And the French team that I was on, or that I led, was tasked to work on the nuclear fuel cycle because nuclear fuel energy production was very important in France. And in the end, we had to report the technical results to government decision makers concerned with both energy production decision making, but also global warming. In this case, it was mainly communicating technical results to lawyers and economists. And after spending 6 great years abroad, I decided it was time to come home back to the US. And a friend of mine was able to find an opportunity for me to apply to what was then called the Arms Control and Disarmament Agency in the US, to be part of a technical team focused on verifying and detecting clandestine activities associated with the prevention or the prohibition of nuclear testing. So it was towards the end of the Comprehensive Nuclear Test Ban Treaty negotiations that I became part of the technical team looking at how you could use radioactivity detected in the environment to determine whether or not there had been a clandestine nuclear test in violation of the treaty commitments. It was, again, just chance. It took a real change in my career. I had been working on health and environmental risks, and now I was working on national security and the risks associated with that. This team interacted with international technical experts and diplomats, in this case, to find the best way to verify this multinational treaty. And so I moved to Washington, D.C., and very much got into international security issues. Ultimately stayed in ACTA. We were integrated in the State Department, where in the end was head of the office that did verification and compliance for nuclear non-proliferation and arms control treaties. Okay, so after 8 years in Washington, which I really enjoyed, and if you, those of you who look to work for government, to go to your capitals and get involved in agencies in your capitals doing this kind of work, even if it's not something you want to do forever, it gives you very good insight in the kinds of information that are needed and how you can make a difference in the work that you then do. So when I returned to Lawrence Livermore National Laboratory, it was a different kind of job than I had the first time. I wasn't doing environmental protection. I was doing non-proliferation, nuclear security, and arms control. And I did that, as I said, for about 10 years before I moved to the center that I'm in now. So in this final part of my talk, because I feel like I've been talking too much about myself, I did it because I wanted you to get a sense of the twists and turns and the different kinds of things you can do if you take what you learn and leverage it into the next project or the next job that you might want to get. I have enjoyed very much facilitating the communication between technical work and policy community, and I find that the policy people think I'm a technical person and the technical people think I'm a policy person, and I don't know if that means I'm succeeding or I still have a lot more work to do, but I really enjoy it. I think that we really do need people who are interested in being interpreters between these two communities. And you can do that, for example, by, I think in the panel it was mentioned that there was a student that took a nuclear engineering bachelor's and then went into international relations in their master's and continuing education program. So if you do something like that, even if you just take the opportunity to take one course or two, it allows you to understand and be in a better position to interpret between the two. So in this final section of the talk, I want to give you a little bit of an idea of the kind of projects that we do at Livermore, and particularly the ones that I was involved in, supporting these kind of nuclear security issues. And as I said, we got to work on what the U.S. government sets out as its goals and objectives in these areas, and we help provide those technical solutions. But we also do a lot in international cooperation and engagement and capacity building. And so again, I'll go over it fairly quickly. I'll be happy to answer any questions later. When I first came to Livermore, came back to Livermore in 2003, there was the Nunn-Lugar Cooperative Threat Reduction Program, which I don't know if you guys have had a chance to come into contact with, was still going in full swing. It was a program put together after the fall of the Soviet Union with the intention of reducing nuclear dangers that came about as a result of the breakup of the Soviet Union, to look at safety and security, to look at reduction of facilities and weapons, and do it in a cooperative way. And so I was asked to be part of a steering committee that oversaw and approved what projects might be done between US and Russian scientists and technical experts. It was called the Warhead Safety and Security Exchange. It ran for about 10 years, and I was involved in the last few years. And we had symposium, conferences, we exchanged papers, but we actually did some real projects on nuclear weapons security and emergency response near nuclear facilities. But that ended in 2005. We also had for many years programs called the Sister Labs, which were intended to bring our technical specialists together with technical specialists in countries that wanted to develop nuclear fuel cycles, and to help them put together a safe, secure, and safeguardable nuclear fuel cycle. So everything from emergency response, waste management, nuclear safeguards. It would depend on the country. It would depend on what they were trying to do. We would organize workshops and efforts to help them do things in a way that we thought was in line with nonproliferation goals and objectives for the world. I was able to work on one with Morocco. Livermore had a long-standing cooperation with them. And we even brought together all sorts of expertise. We had South Korean experts who had undertaken that effort in their own nuclear fuel cycle to come and tell what they had done in their country to the Moroccans. In 2008, 2009, I think there was a mention of it earlier, the Department of Energy, National Nuclear Security Administration decided to embark on what was called the Next Generation Safeguards Initiative. The intention was to establish a framework that would bring together their program on technical research and development, international capacity building, and developing the next generation of safeguards experts that could go on and support national programs as well as the IAEA. I worked with headquarters staff to put together this program, and one of the first things we did was create the course, Elena, that you mentioned, an open source information analysis here at Monterey with a follow-on intern program for 6 or 8 students. I think it varies year to year, continuing at Livermore within our program. One of the really exciting things that I was involved in was trying to reinvigorate a US-Russia lab directors cooperation program. Again, after the fall of the Soviet Union, our lab directors got together with Russian counterparts at their nuclear security laboratories and said, we need to work together, we need to understand each other, greater confidence building and transparency will help our national security and international security. And so I was the Livermore point of contact working with Los Alamos National Lab and Sandia National Laboratories and our 3 counterparts in Russia to put together an invitation for them to visit our laboratories and for them and then us to visit theirs. And this resulted actually in a research and development agreement that was signed between the 2 countries to promote the types of cooperation we could do between our laboratories. Unfortunately, right now it's paused, but it hasn't been killed. So we're still hopeful that as relations change, it might be the ideal opportunity to begin confidence building in technical kind of cooperation on some of these important topics. You mentioned START Treaty. I was recruited to be a support person as part of the New START negotiations in Geneva in 2014 and 15. And though I wasn't one of the brave souls that basically spent a whole year, 8 days a week, working on trying to get this treaty negotiated. But I was in and out and was able to really witness firsthand how we negotiate a bilateral treaty with a real variety of both political and technical aspects. I had colleagues who worked very hard on developing how you do the on-site inspections, how you do the declarations, and I was there as a sort of gopher to help wherever I could, because it wasn't my technical expertise at the time, but it was fascinating and it felt really good to be part of that effort. And then the final example that I'll give you is in 2016, in the lead up to the final nuclear security summit that was held in Washington, at the time, our Energy Secretary Moniz came to Livermore and asked us if we would host a ministerial level meeting to bring together his counterparts to really think about and exercise high-level decision-making, the high-level decision-making that would be needed in finding and dealing with nuclear materials out of regulatory control. And so they devised a scenario with a whole series of questions. We had hundreds of people from around the world. We actually had to convert our central cafeteria into a diplomatic meeting room. And were able to put together that type of exercise for the secretary, who then took the results of that to the presidential level security summit in the months after that. Okay, so now I'll just want to sort of close by telling you a little bit more about the Center for Global Security Research. We're a small organization within a big national laboratory, but we were created by the director as a bridge between the science, technology, and national security policy communities. We know that we're a lab full of technical experts, and again, we want to bring to those experts, even if it's not their primary interest, the context and reasons why they're doing some of the work that they do. We focus on emerging national security challenges, and the center particularly looks at deterrence, assurance, and strategic stability. We also look at what we call strategic latency, which is the security implications of new and evolving technologies. We have strong partnerships with a lot of organizations in the US, but also we work to do it abroad, because we want to make sure our work is informed by diversity of perspectives and interests, not just totally US-centric. We have interns. We actually call them research assistants. We host postdocs. We have place for visiting faculty on short-term basis. And so we're very interested in bringing people together to give them the experience of working on these type of policy studies, but also get exposed to the technical people at the laboratory as relevant to their projects. We hold workshops on cybersecurity, space security, extended deterrence, biosecurity, future of arms control, strategic stability are just some of them. And for each workshop, we pull together an annotated bibliography, which we post on our website, which might be something that you would find really interesting, because you can go there and find what we thought were the most relevant documents to become smart fast on a particular topic that were relevant to what our agenda was for that workshop. And then at the end of the workshop, we write a 10-page summary or so on what the discussions were. So you can get a real sense of some of the topics that we're looking at right now and have a sort of one place to go for those kind of resources. We also have a topical monograph series on different topics. We have occasional papers. We videotape our seminars and post them. And so it really could be a good resource for those of you who are going to continue studying this, or even if you're just interested in staying up on some of the current national and international security issues. Our website is simple. It's cgsr.llnl.gov. And so I think you should easily be able to find it if you're interested. So finally, I'll close by saying I've found working on nonproliferation and arms control issues to be very satisfying, whether you're a bench scientist devising new detection techniques and technologies, or a political scientist crafting academic policy studies, supporting international negotiations, or even leading them if you become an ambassador one day. You'll be able to see how what you do makes a difference. And if it appeals to you, my advice is follow your interests, work hard, and pay attention to new opportunities that come your way. Thank you for your attention. So I'm happy if any of you if I haven't all put you to sleep, if you have any questions.
Thank you for the lecture. That was very interesting. And from the more macro perspective, do you think it's possible to shift or build security which does not rely on armaments? I mean, it seems it's our human fate that we develop and possess various weapons to secure our lives. But as we confirmed through this today's conference, now we are living risky and dangerous road because of its inhuman weapons. We think there is a contradiction in current security's concept. So is there any way to defend national states without weapons or armament? Is it possible, do you think?
With any defense or armament, I would like to think that the world could become that way, but I think that the way we are now, well, as long as there's adversaries and conflict over regions or different ideologies, I think national defense is necessary. I like to think that deterrence stops conflict, and it doesn't only have to be nuclear deterrence, it's deterrence in general. And I think that one of the things that having military capabilities does is deter action. And I mean, I'd really like to see a world where we didn't need it, but, and maybe you as the next generation can figure out how to do that, but the way things are right now, I think it would be very hard.
Okay,
Sorry
thanks.
to say.
Yeah, thanks.
Hello, my name is Marturia, and I'm currently a senior in high school, and so for my senior topic, I'm doing a lot of research and research projects on women in STEM and kind of their experience throughout it. And you know, you have a very extensive career in the sciences and even in policy. So I was wondering, like, what is your experience, or like, what are the challenges that you as a woman have faced in those fields, and like, what are some things that you've done to overcome them?
Oh, that's a big question. So I'll start out by saying the world has changed, though maybe not as much as I had hoped it would over the years. Some of the challenges I have come up against have to do with style and personal style. When to be assertive, how to make yourself heard, when to have the confidence in what you think is the right answer, and to negotiate around people who are much more confident or more willing to be assertive than I. So there have been numerous times in my career where the challenge has been to be heard, or not to just be the person working hard in the background and not recognized because I wasn't good at promoting. So the balance between promoting yourself and having it be known what your capabilities are and what you can do sometimes gets hard, or is harder for some women. I don't want to generalize because I don't think it's true for everybody. Over the years, what I've found is two things. One is finding mentor, somebody whose style and capabilities I respect and could imagine being like. So not any mentor, because some people, they might be succeeding, but I can't imagine being like them. So I would find, and then finding a way to engage those people to have that mentoring opportunity. The other thing that I found really valuable is networking. I mean, there's a lot of networking opportunities for women's networking, but I think networking in general is just a good idea because you hear other people's experiences, you get to learn from it. You actually find out some places that might not be a good place for you to go work because what the environment is and maybe the way they don't respect women as much as you would like. So finding out and working with people shows you opportunities, but it also gives you a chance to find out what some place is like as to whether or not you think you could fit in and excel in that environment. But, you know, there was a time that I thought that the world had completely changed, but I'm not sure it has, so I think it continues to be a challenge. One thing you could do is look up, there's an organization called WISE. I think it's Women in International Security. It's based in Washington, D.C., and it's a network information and job hotline, and it might give you some information you'd find useful.
Thank you.
Sure.
Thank you so much. You've had such an interesting career. I was just curious, one thing we haven't talked a lot about at this conference is the military-industrial complex and its role in promoting the weapons that it builds. And I'm just wondering if you encountered that in all of the various areas of the field that you have been involved.
So I didn't encounter it very much until this last stage, and I have to say it's been very interesting for me to now work in a center that's focused on deterrence, you know, assurance and strategic stability, because it's actually exposed me to more and more what national defense infrastructure, I mean, in my case it's mainly the US, but all nations look to protect their own security. The kind of thinking that goes into that and the kind of need for risk reduction or mitigation of threats that goes on. And so for years, I really believed that we should just get rid of nuclear weapons. Why can't we get rid of them tomorrow? And the more I deal with that side of security and defense, the more I understand what the risks are and what we're trying to do. And so, you know, I heard today talk of just, it's a lot of cost and effort put in to establish the military infrastructure, and therefore we're just trying to protect it because we've done that already, that nations who put in that money want to protect it because they put in the money. And I won't say that there may not be an element of that, but I think to a large degree it's really national security that starts to change, you know, what you can do and what's possible. So for me, I actually, the first time I worked at Livermore, I never had any exposure to the weapons side and the security work that they did there. I didn't want anything to do with it, wasn't interested. In this new job, I've actually been put in a position where even if it wasn't my choice to study it, I hear about it, I know about it, and it's learning more about it is really useful because it may or may not change your point of view, but it's more information, it's the other side of the coin. I think it's useful to know more about it.
Hi, I'm Karen Gordon from Pacific Grove High School. And I just wanted to ask you, you talked about what do we do when we detect noncompliance. And I think that one of the things that's arisen in our studying of the INF Treaty and Donald Trump's decision to pull the U.S. out is he was citing that experts have said that Russia is not complying with the treaty. So what role does Lawrence Livermore National Laboratory play in the verification and detection regime of the INF Treaty? I know you mentioned that you have a large role in the New START Treaty.
We don't. I don't know if we did in the past. There's actually on our website, one of our interns did a paper at looking how technical input made a difference in the INF Treaty negotiations. And she basically outlines the work that Sandia National Laboratories did that helped the negotiators decide what they could or couldn't accept as part of the verification regime for that treaty. And so you can go on online and find it. It's Henrietta Toivonen was the student that wrote that paper. She interviewed a lot of first sources, people who were actually part of the technical teams and part of the negotiation team. And we did it because we were interested to see how much does technical expertise make a difference, and that was a case study. But today we're not, as far as I know, maybe there's another part of the lab, but as far as I know, we're not involved. Where could we find that? cgsr.llnl.gov. It's on our website. We have all our publications, and we also have a tab for the products from our student interns. so you could actually go there and find it maybe easier. We also, on that website, if you're interested, we post who our interns have been and the studies that they did. So you can actually go get an idea of who has been there in the past and who's there now. Okay? Thanks. Thank you all.